Hello and welcome back, Math 140 students. We're going to continue on with our lecture, doing this remote online classes. I'm your instructor, Cindy Enrigue, and here we go. So first of all, this is section 5.4. So I do apologize right off the bat. It says section 5.3, but this is actually section 5.4. Okay, so this is a bit of a typo, and that's okay. It's our first typo, and I think this is the only typo that we have in this section. So what we're doing in section 5.4 is we are visiting the rules of exponents, and we are multiplying monomials together. So we're going to go over a few examples first. So the first one is the product rule. When I have the product rule, if you have to have the same base, remember, these are all with the same base. For example, if I have x to the m, then the same base would be x as well. But let's say we have a different exponent. Well, what you do with the exponents is you actually add them together. So it'd be m plus n. So for an example, using some numbers, if I have 2 to the third, well, the same base is 2, and let's say we have a different exponent. Let's say it's 4. Then we would add those exponents together, and 3 plus 4 gives me 7. For our next one, our power rule, we have x to the m being raised to the n power, then what you do is you actually multiply those powers together. For example, if I have 2 to the third power, all to the fourth power, then I'm going to multiply that 3 times 4 to give me 12. So now it's 2 to the 12th power. And our 0 exponent means anything to the 0 power is always equal to 1. It doesn't matter how crazy I get with my notation, if I have alpha or sigma or psi, if it's to the 0 power, phew, it's just 1. Doesn't matter how crazy it gets. And for our negative exponent, we don't like negative exponents. We can think of it as, oh, it's a sad exponent. It's not in the right place. So in order to make it a happy positive exponent, we move locations. So for example, if I were to have, let's say, 2x to the negative 3. Well, the only thing that's sad that has a negative exponent is that x. So the 2 is fine, leave it alone. The only thing that's sad is the exponent of 3 on x, so x gets moved down to the bottom. And for the quotient rule, if I have x to the m over x to the n, then when we do with the exponents, we are actually subtracting them. For example, if I had x to the fifth over x to the third, then I'm subtracting the exponents. So 5 minus 3 gives me 2. So now I have an x squared. So that's just a brief overview of our exponent rules. Now we're going to put these into play with some examples. So we have 3 squared times 2 to the fifth. Notice how these are the same base. These are both 3's. So I have 3, 2 plus 5. We were adding those together. So that's going to give me a 3 to the 7th power. We're just getting used to the rules. For number 2, everything is being multiplied. And in multiplication, order does not matter. For example, 2 times 3 is the same as 3 times 2. So in multiplication, it's commutative, meaning the order doesn't matter. So I'm going to rewrite this. I'm going to write this as 9 times 3, y to the 5th, times y to the 8th. Usually this helps students to notice that numbers get multiplied together and the exponents get added together. So now I have 9 times 3, which is 27, and I have y to the 5th times y to the 8th. So our rule of exponents tells us that it's the same base being multiplied, so our exponents get added together. And 5 plus 8 is equal to a positive 13. So I'm going to use that same rule where multiplication is commutative, and I'm going to apply that to number 3, since it's a little bit longer. So now I have a negative 5, 6 being multiplied by 2 thirds. I have an a squared, and I have an a to the 5th, I have a b, and a b to the 4th, and I also have a c value as well. So when I multiply my exponents together, and go ahead and use your calculator if you need to. So I'm going to have my fraction of negative 5, 6 being multiplied by my fraction of 2/3, and I get a negative 5/9 since that's nice and reduced. So I have a negative 5/9. I have an a, and 2 and 5, if I add them together, it's going to give me 7. And I have b to the 5th power, and I have c. So now I have negative 5/9, a to the 7th, b to the 5th, and c to the 1st power. Hopefully this is making sense to you guys. And for number 4, now we're going to have our rules of exponents, where we are actually going to be using the power rule. So here, this 3 gets distributed. I can think of that 5 having an exponent of 1, so I'm multiplying that 3 in. So I have 5 to the 1 times 3, and a to the 6 times 3. So this is my exponent rule. So now I have 5 to the 3rd, and a to the 18th. And actually simplify this a little bit. 5 times 5 times 5, 5 cubed is 125. And I still have a to the 18th power. For number 5, it's the same thing. We have our rules of exponents. Now I want to be careful because it's a fraction that's negative. So okay, I have a negative 5/3. Right now it's an exponent of 1, and it gets multiplied by that 3. So that gets distributed here, gets distributed to the 2, and also to the u. So now I have 2 squared times 3, and u to the 6 times 3. So that 3 is being multiplied by each individual exponent. So now, negative 5, so really I have negative 5/3 to the 3rd, t to the 6th, and u to the 18th. Now, for the fraction, negative 5 times negative 5 times negative 5 is a negative 125. And down at the bottom, 3 times 3 times 3 is 27. And I still have t to the 6th and u to the 18th as my final answer. So hopefully that makes sense to you guys. And I know this can be a little confusing for students when they first see it. So I'm definitely going to be going over these practice problems. So here, these practice problems. So when I see this, I know that I have A's and 1B. And remember, multiplication is commutative. I can multiply in any order. So this is really a to the 3rd times a squared times b. So now I have a to the 3 plus 2 times b. So I have a to the 5th times b. And so that's going to be my final answer there. Here, for number 2, I'll give you a moment to think about what you want to do. That's right, it's commutative, multiplication, so I get to rearrange the order. So I'm going to have negative 2 times 4 times m squared times n times n. So this is going to give me a negative 8, m cubed, and an n squared. And so that's going to be my final answer for number 2. I also have the same thing going on for number 3 and number 4. It's all about rearranging so it makes your life a little bit easier when you're nice and organized. So I'm just going to rewrite this. So I'm going to have my 5/8 times my negative 2/7. Number times a number. I have an s and an s squared. I have a t and a t to the 7th. So now that I group them together, it makes my life a lot easier. Notice that on this s, there is an exponent. We can think of it as a 1. Same thing with the t, we can think of it as a 1. So now I can multiply these together. So when I multiply these fractions together and simplify, I'm going to have a negative 5 over 28. I have an s to the 3rd power and a t to the positive 8th power. For number 4, same thing. Multiplication is commutative. So I have a negative 5 times a negative 1 times a 4. Yes, this negative here, I can think of it as a negative 1. Now my m's, I have an m, I have an m to the 3, and I have another m to the 3rd power. And now I'm going to have an n to the 4th, an n to the 9, and another n. So when I multiply my numbers together, negative 5 times negative 1 times 4 is a positive 20. And remember, when there isn't an exponent, it can default to be a positive 1. So now I'm going to add these exponents together, 1 plus 3 plus 3. That's going to give me an m to the 7th power. Now I look at my n's, 4 plus 9 plus 1. That's going to give me a positive 14. And so that's going to be my final answer. For number 5, this is where it gets a little confusing because it's that scientific notation. So you have to remember your definition. I know that the scientific notation, you have a times 10 to the nth power, where you have a is greater than or equal to 1, but strictly less than 10. So it has to be between 1 and 10. So you really want to be careful about how you multiply these and in what order. Again, if this is just all multiplication, so I'm going to think of this as 2 times 6 times 10 to the 5th times 10 to the 3rd. It's all being multiplied. So here I have 12 times 10, and 5 plus 3 is going to give me 8. So I can think of this as 12 times 10 to the 8th power. The problem here is that this 12 is bigger than 10. So this is not in scientific notation. Because scientific notation, it has to be strictly less than 10. So in order to do that, I need to say that this is going to be 1.2 times 10, and I have to adjust my exponent accordingly. So in order to do that, if I have 12, if I add another movement, then I'm going to add 1 to the exponent. So it's going to be 1.2 times 10 to the 9th. So let's see if we can think about that again using problem number 6. So problem number 6, I'm going to rewrite it. So I have 7.2. It's being multiplied by 4.6. And I have 10 to the negative 2 and 10 to the positive 7. So 7.2 times 4.6, that gives me a 33.12. And now I have 10, 7 and negative 2 is going to give me 5. But here, that's too big, this 33.2. This is not in my definition of scientific notation. So I really want to make sure that that number is between 1 and strictly less than 10. So it's going to be 3.312 times 10, and since I move the digit 1 more, then I add 1 to the exponent. So now it's going to give me 3.312 times 10 to the 6th power. And don't worry, you guys will have plenty of time to practice this on your homework. So for number 7, if I'm thinking about this one, I really want to think about what's happening here. I have this 4 that's getting multiplied inside those parentheses. And I also have this 3 that's being multiplied inside those parentheses as well. So I really have 2 times. And over here I have 2 to the 4th power and x to the 4th power. And now I have 4 to the third power and y to the third power. So if I were to rearrange these, I have 2 times 2 to the fourth times 4 to the third power, x to the 4 and y to the 3. So now when I multiply these numbers together, 2 times 2 to the fourth times 4 to the third, that's going to give me 2048, x to the 4 and y to the 3. And usually what we want to do when you have different variables is write it in alphabetical order. So write variables in alphabetical order. Whenever possible. So I'm going to try to do the exact same thing over here for number 8. I see this 2 inside parentheses. So I'm going to have a 6 squared times u squared. I see this set of parentheses, but there's nothing here, so I'm just going to rewrite it. U squared times v. And then over here, I'm going to have this 2 that's going to get distributed inside those parentheses. So now I have negative 3 squared, u squared, and v squared. So I'm going to rewrite it so I have my numbers first, and then my variables according to alphabetical order. So I know I have my 6 squared, dealt with that. I have my negative 3 squared, dealt with that one. Now I have a u squared, and a u squared, and another u squared. And I have a v, and a v squared. And I just cross them out so that way I don't lose track of what I'm doing. So now I have 6 squared times negative 3 squared. So 6 squared times a negative 3 squared. Well, when I multiply those together, I actually end up getting 324. When I multiply all of my u's together, I just count them out. So 2, 4, 6. And my v, count your v exponents. Remember, if one of your variables doesn't have an exponent, it defaults to an exponent of 1. So now I have v to the third power. So now I have my answer of 324, u to the 6, v to the third power. So I really want to make sure I gave you guys as many examples as possible because you're going to need them. Okay? Well, good luck on the homework, and don't forget to try your best. And if you have any questions, you guys can always email me for anything. Okay? See you guys for next video.